Hello everyone. Today we're diving into the fascinating world of recursion. Recursion is all about self-referencing functions. Think of it as a function that calls itself to solve a problem. We will explore how recursion applies to different things, from Fibonacci sequences to fractals in various computer algorithms. In the diagram below, we can see that the function f of n calls the function f of n minus 1, which in turn calls the function f of n minus 2. This process continues until we reach a base case which stops the recursion. Let's define recursion properly. Recursion is a programming technique where a function calls itself to solve smaller instances of the same problem. A key concept in recursion is having both self-reference and a base case. The function calls itself, which is the self-reference, and the base case is the condition that stops the function from calling itself again and again. Every recursive function needs two key components. Number 1, the base case. This is the stopping condition that prevents the function from calling itself again and again, hence preventing infinite recursion. Number 2, the recursive case. This is where the function calls itself with a modified parameter. This parameter brings the function closer to the base case. Let's look at a simple example. The factorial function. Here is the Python code. We define a function called factorial that takes one argument. If n is equal to 0, we return 1. This is the base case. Otherwise, we return n multiplied by the factorial of n minus 1. This is the recursive case. The base case, n equals 0, returns 1. The recursive case is n multiplied by factorial of n minus 1. The function breaks down the problem into smaller, self-similar subproblems until it hits the base case. Let's trace the execution of factorial of 4. First, we call factorial of 4, which equals 4 times factorial of 3. Then we call factorial of 3, which equals 3 times factorial of 2. Next, we call factorial of 2, which equals 2 times factorial of 1. Then we call factorial of 1, which equals 1 times factorial of 0. Finally, we call factorial of 0, which hits the base case and returns 1. Now let's discuss the Fibonacci sequence. The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones, usually starting with 0 and 1. Here's the Python implementation. We define a function called Fibonacci that takes one argument, n. If n is less than or equal to 1, we return n. Otherwise, we return Fibonacci of n minus 1 plus Fibonacci of n minus 2. The sequence looks like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. Notice the golden ratio pattern within the sequence. Let's explore the relationship between fractals and recursion. Fractals are geometric shapes that exhibit self-similarity, meaning they show the same pattern at every scale. A perfect example of a recursive structure is the Sierpinski triangle. You can see the same triangle pattern repeating within itself at smaller scales. The repeating pattern makes fractals very suitable for recursive algorithms. Now let's discuss tree traversal algorithm. Recursion is often used in algorithms involving trees. Here's the Python code for a recursive traversal function. We define a function called traverse that takes one argument, node. If node is none, we return. Otherwise, we print the node value, then traverse the left child, and then traverse the right child. This method can be used to navigate a binary tree where each node points to two other nodes. Like any tool, recursion has its advantages and disadvantages. Let's begin with the advantages. Recursion often leads to cleaner and more elegant code. It is a natural fit for problems involving trees or fractals. Recursion can make complex algorithms easier to understand and often mirrors mathematical definitions closely. Now let's look at the disadvantages. Recursion can lead to higher memory usage due to the call stack. There's a risk of stack overflow if the recursion goes too deep. It can sometimes be slower than iterative solutions, and recursion can be harder to debug. In summary, recursion is a powerful programming technique where functions call themselves. It requires a base case and a recursive case to solve problems elegantly. From simple calculations to complex fractals, recursion reveals the beauty of self-reference. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.